All right, simplifying algebraic fractions. Apparently, it's easier to simplify fractions than it is for me to talk. Let's go. All right, so simplifying fractions is very useful in some areas, but this is just a neat way to see it. So most of you guys, oh, please don't freak out. I know it's fractions. It's really not that bad. All right, so if you look at these three pictures here, they have the same amount shaded. So if I look on the one on the left, I've got like that much of it done. So if I counted up each one of these sections, there'd be 15 of it, and there's 60 total. In this case, there's 3 out of 12. In this case, there's 1 out of 4. So are these three fractions equivalent, as in 15 to 63 to 12 and 4? Yes, they would be. So which figure is divided into the least number of parts? Well, there's 60 parts here, there's 12 parts here, there's 4 here, duh. So the third one, because that has the least amount. So which fraction would you say, fraction, sound like I'm doing the, oh, what is the movie that had the factions of people? Anyways, moving on. So which fraction would you say is written in the simplest form? I'd say the one at the end. All right, so simplest form is a fraction in simplest form when the greatest common factor of the numerator and the denominator is 1. So fractions in simplest forms, if it's got a 1 on top and a number on the bottom, you're good. If it can't be reduced anymore, then you're also good. Like if they're both greatest common factors, you're also good. You know, there's a prime number here, so that one's not going to reduce anymore. These are not in simplest form. So this one could go to 1 over 4, because I could divide both by 3. 15 over 30, both could divide it by 5. So that'd be 3 over something. These can both divide it by 2, so 3 over 4. 5 over 20 also goes to 1 over 4, because I can divide 5 into 20, or 5, divide by 5, divide by 5. We'll get there. All right, so write this in simplest form. Now, the book has a couple more steps. If you get stuck, do this way. So don't forget what this is. I know some people get to the point where they can get a little past it, and that's fine. But if you get stuck, remember how to do this. So make sure you get this down really well. So write this in simplest form. So first we're going to factor the numerator out. So 2 times 2 times 2 times 2. So yes, you'd have to do the factor tree. That's fine. There's nothing wrong with that. Get it right. Okay, and 24, it's going to be 2 times 2 times 3. 2 times 2 times 2 times 3. Factor the denominator. I find the greatest common factor of those. Multiply that out. It's going to be 8. So now I can divide both sides, both the numerator and the denominator, by 8. So take that number, divide it by 8, divided by 8. That's going to come out to 2 over 3. So that would be the simplest form. All right, try that one out. Try the whole steps. I know you might skip a step. Don't do it. Okay, so we're going to factor tree both these out. So 12, actually I already know what 12 is. So 12 is 2 times 2 times 3, because it's 4 times 3. 40, we'll do the tree on this one. 2 and 10. 2 and 10, that's going to be 2 and 5. So 40 is going to be 2 times 2 times 5. So my common factor is going to be 4. So I'm going to take 12 divided by 4 and 40, divide that by 4. So it's going to come out to 3 over 10. All right, write this one in simplest form. A little more complicated, not quite as easy to see just right offhand. So this is where you're going to have to go into the numerator and denominator. So divide the numerator and the denominator by the common factor. So after they skipped a whole bunch here. So they first factor treed. They crossed out the ones that didn't count, or that would end up being kind of countering each other, because if it's on top and bottom, counter them off. So they'll end up leaving you with 3 over 5. All right, try this one in simplest form. So again, you're going to have to do 48, 2 and 24, 2 and 12. 12 is 2 times 3. And then 80 is going to be 2 and 40, 2 and 20, 2 and 10, 2 and 5. So I've got 1, 2, 3, 4, 1, 2, 3, 4, and 5. So how the book just did it there, and they skipped a bunch there just a second ago. So they did 48 and 80 like this. And they said those equal 2 times 2 times 2 times 2 times 3. And then 1, 2, 3, 4, 2 times 2 times 2 times 2, and then times 5. So if they're above each other like this, I can actually cancel each other out. So because 2 divided by 2 is 1, 2 divided by 2 is 1, 2 divided by 2 is 1, or you can just kind of go cross that one out, cross that one, nope, 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 and it's left with 3 over 5. So that was what they did really fast over there. All right, 250 pounds is what part of 1 ton? Well, first you need to know what's 1 ton. So there are 2,000 pounds in 1 ton. So if I need to find out what part of something is, that means make it a fraction. So 250 over 2,000. So the fraction of 250 over 2,000 needs to be in simplest form because it's not right now. So they factor treed them out and then canceled. You know, these two canceled. This one canceled with this one. So now we're left with 1 on top and 2 times 2 times 2 on the bottom. So 1 over 8. So 250 pounds is 1/8 of a ton. Right, 80 feet is what part of 40 yards? Well, first thing you got to come up with is 40 yards. 40 yards, how many feet are in a yard? 3. Thank you from the person in the back of the room over there. So I'd have to go 3 times 40 would be 120, so 120 feet. That's what that would be. So 80 feet, so if I went 80 feet is what part of, I hate it when it does that, 120. Now we need to figure out how to reduce this. Well, I will just look at this and say, looks like 40 is going to go into both. Because if I put this into 40, is going to go in here twice. Divide this by 40. It's going to come out with 2 over 3. I also just kind of looked at 8 and 12 and just put a 0 on the end. So that's how we came up with that. You could, if you're stuck, please do the factor tree. But if you can see it, fantastic. All right, simplify this out. So we saw that if you had a 2 on the top and a 2 on the bottom, in the numerator and denominator, they canceled. Well, same concept is going to go for exponents, which we learned the other day. So first we divide the numerator and the denominator by the greatest common factor, which is 5m and n. So we canceled out 5, we canceled out 1m and 1n. That left me with 2 times 2, so I'll have 4 on top, 2 m's and an n, over 13. All right, you try. All right, so first we're going to prime factor these out. So 14 is going to be 2 times 7, and then 4 x's. See if I can draw these. And 2 y's. And then 49 is going to be 7 times 7. Then I have 2 x's and 5 y's. I was doing so well with these 2 y's. All right, so this one cancels, this one cancels, this one cancels, this one cancels, this one cancels. That one does not. So I'm going to have 2 over 7 and then 2 x's on top, x squared. I'm going to have 3y's on the bottom. Hey, I like it when it all works out. All right, write this one in simplest form. So there's a couple ways you could do this. One, you could write it all the way out, which is fine. And let's see, so simplest form means the greatest common factor of the numerator and denominator is 1. So solve the test item. First we factor it out, cancel out whatever we can, which leaves me with x over y. The other thing you could have done over here is gone 3 over 1 and just left 1 on top, 3 over 2, leave 1 on the bottom. It's another way to do that when it's just x and y. So the answer would have been C when we went back and looked. Go ahead and give that a shot. All right, so if we factor it out, I'm going to have m times n times p. Yes, I hear all of those middle school people giggling about, oh, you said p. So I have m, and then 3 n's, and then 2 p's. Cancel, 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 cancel. So I'm left with m and then 2 p's. Oh, so that'd be actually mp squared over 2n squared. So I think it's a D. Hey, we're right.